Many NLP problems involve converting one sequence into another, translating a sentence, summarizing a document, or generating a response. This is the domain of sequence-to-sequence models, and a critical component within them is the attention mechanism. A basic sequence-to-sequence model consists of two main parts, an encoder and a decoder, both typically built using RNNs or LSTMs. The encoder reads the input sequence, example, an English sentence, word by word, and processes it to capture its meaning into a fixed-size context vector or thought vector. Once the encoder has processed the entire input, this context vector is passed to the decoder. The decoder then takes this context vector and generates the output sequence, example, the French translation, word by word, predicting one word at a time until an end-of-sequence token is generated. While effective for shorter sequences, a major limitation of this basic sequence-to-sequence architecture is that the entire input sequence must be compressed into a single fixed-size context vector. For long sentences, this bottleneck can lead to information loss, especially for early parts of the input. This is where the revolutionary attention mechanism comes in. Instead of forcing the encoder to compress everything into one vector, attention allows the decoder to look back at different parts of the input sequence at each step of generating the output. It essentially weighs the importance of different parts of the input when generating each word of the output. Imagine translating, "The cat sat on the mat." When the decoder translates mat, it pays more attention to the words cat and sat in the original sentence. Attention calculates a score for how relevant each encoder hidden state is to the current decoder hidden state, then creates a weighted sum of those encoder states to form a new context vector for the decoder. This dynamic access to the entire input sequence, rather than just a single fixed context vector, allows sequence-to-sequence models with attention to handle much longer sentences and achieve significantly better performance in tasks like machine translation, text summarization, and question answering. The attention mechanism was a game-changer in NLP, addressing the long-term dependency problem more effectively than LSTMs alone. It paved the way for even more powerful architectures, which we'll discuss next: the transformers.